Everyone in? It's only 7 people in the audience I recognise, which I think means the rest of you must be here because you're interested in the content, which is awesome. Thank you all for coming. This is Craig McCormick. He is Xero's man of steel, the QA practice lead. It's his first time at Ignite, so please be nice to him in your session feedback.
Thank you. And this is Ben Moore. He's a developer practice lead at Xero, in charge of our development team of about 70 developers across Wellington.
Is it 70 now?
I think so, yeah. Yep.
I should know this really. How many QAs? How many QAs have we got?
About 30, 35.
That's actually a big team. It's worrying. Anyway, we're here because I guess I think we're doing something that's a little bit ahead of the curve with our QA practice and our tooling. And this isn't going to be a great flag-waving exercise about how Xero is the greatest tech shop in New Zealand. Obviously, I think so. That's why I went to work there. But the point of this exercise is not that. The point of this exercise is to share with you some of the learnings from our journey to automating our testing. And I'm sure that lots of other people have got things that their organisations are doing really well as well. So this isn't crowing and saying we're great. A little bit of background about the tech stack of Xero. When you think about Xero, if you think about Xero, I don't know, do you think about Xero? I think about Xero quite a lot. Maybe you don't think about Xero quite so much. If you think about Xero, you probably think about the accounting product. You probably think about what we call Blue Xero, the thing that we're selling. There are about 40 products in the Xero universe. So there's a subscription engine, there's a marketing website, there's a thing that accountancy firms use to manage their customers. But most of what we're talking about today is centered around the accountancy product, Blue Xero. Most of our stuff is built on straight up Microsoft stack. So a mixture of MVC and our own homebrew MVC sitting on web forms in the front end, C#, SQL Server at the back end. There's outbreaks of Cassandra and Redis and that kind of thing, but it's pretty much straight up and down Microsoft.
So what's our problem? So I'll start with my problem at the moment. Ben came to me with an idea that we should present this at Ignite. Ben's brilliant, obviously. He's a highly skilled speaker. He's witty and he's confident and all of the above.
I would like you to put that in your session feedback. Oh, actually, just tweet that now. That would be wonderful. Thank you.
I'm not a skilled public speaker. I've got a bit of a monotone voice. I will probably talk too fast at some point because I'm nervous. That's just how it's going to be. I guess what I'm trying to say is that, and you know, correct me if you recognise this behaviour, but as a QA, if this all goes terribly wrong, it's not my fault. It's his fault. He developed it. And that's really the point, right? So QAs and developers have been working in this kind of relationship for a while now, and it's dysfunctional, and it doesn't work very well. Agile tries to solve it. That's what we're trying to do at Xero, is to solve that problem, this dysfunction of something's gone wrong and it's all your fault. I am clearly involved in this. I do have something to say about the outcome of this. It does matter to me as much as it matters to the developer building it or to Ben presenting it with me. So our problem at Xero is that we've got a big old code base. We've been developing code for about 7 years, and we've been attaching to it and attaching to it and attaching to it. We move fast as a company. We're a first to market company. We do lots of things that help us iterate on that code base, but we do them with speed, which means that they're not well automatically tested, so they don't have a lot of unit tests around them. They don't have a depth of test. It hasn't been built in a way that makes it easy to test either, and it's a humongous monolith. Typically, when we release code, we do manual regression testing. That's useful, but obviously as the size of the product grows, that becomes harder and harder to continue to move fast. And we want to move fast. We have to move fast, and we want to be able to scale out our product to, 2 million, 3 million, 4 million customers. So we want to talk about CI and how do we move from this manual regression phase into a CI phase.
So given that we've got this reasonably legacy product, and we want to move to a live continuous delivery model, how do we get there? This kind of reminds me, about 10 years ago, I'm from the UK originally, and I got a phone call from a mate of mine who I used to sail with. And he said, Ben, you've got to come and join us. we're on the boat, and we're at a place called Beer Island. Right, I'm there, and I had some leave to take, so I went to Birmingham Airport and I flew to Cork, which was the nearest place to Beer Island, which is in the southwest of Ireland. And I got out of the terminal and I went to the cab rank and I said to the cabbie, I said, I want to get to Beer Island. What's the best way to do that? And he said, well, you don't start from here. And I thought that's not very helpful, mate. Okay, but let's move on. And we're kind of in the same place. You know, we've got this code base which doesn't support the way we want to work, and we want to get to the utopia of Beer Island.
So kind of to give you a little bit of a how to test an application 101, you can do it a few different ways. You can do it manually with hiring a test pool of people to go through and diligently exercise your code, explore how it works. That's kind of what we've been doing, and this is really outsourcing a little bit of the problem of testing, so especially at a unit level. Or you get developers to automate code using unit tests, integration tests. Those are generally really good, but if you're a QA and you're on the other side of that, you have no exposure to do it. So whilst they can be really good, there can be lots of coverage. There's also a lot of duplicate effort, and equally, bugs come out of that. So although there's lots of tests, there can still be potential problems as you move up the stack to pre-prod and out to live. Or you can do it another way, and you know, you can add on different things as well. But you can hire kind of QEs or quality engineers or test engineers, and they typically come in with specialist tooling, quality center, expensive specialist tooling that is really their own domain. And they'll go and automate a bunch of things, but again, it's now the other side, so they have all of the knowledge about what's tested, and the developers have none, and the developers frankly probably don't care either because they couldn't investigate those failures anyway. So what they do is they just respond to bug reports, which isn't really the ideal for fail-fast type of delivery, where you really want developers to see as they make code changes what breaks, and then be able to respond to that in a way that makes sense, rather than going, well, this automated test in a language and a toolset that I don't understand is broken. I don't have a license to view how to fix that test, and I'll just leave it to you, QE, quality engineer. So we were thinking about what we could do, and is there another solution? Is there something else we could do?
So you've probably seen something that looks a bit like this diagram before. Has everyone seen this kind of test pyramid diagram? Okay, like, not that many actually. All right, I'll talk through it, I was going to sort of race through it, but I'll talk through it. At the bottom, you've got a broad base of unit tests. And these are your tests of individual units of code, individual business rules. These are your tests that say people whose names begin with T get charged more, or whatever it happens to be. Above that, you've got integration tests. And I don't want to get into a big debate about whether a unit test should test at the system boundary as prescribed by St. Kent of Beck, or whether a unit test should test one thing in isolation, and the difference between isolating the system under test and isolating the test from other tests. Yeah, that's for another talk. For the purposes of this, a unit test tests one unit of code. Integration test tests the interactions of a few units of code. So the integration test asserts that the developer has remembered to connect the rule that says people whose name begins with T pay more has been hooked up to the payment service. Your API tests start up at the controller layer. They leverage the whole stack, so they're now involved in things like databases and possibly endpoints, that kind of thing. And your UI tests run in the browser using something like Selenium, and they assert that your front-end devs have been talking to your back-end devs, and that you can go to production without upsetting anyone too badly. As an aside, I don't think this pyramid is actually a great representation of that. It kind of implies that you get more coverage out of your unit tests than your UI tests, and that's probably not the case. Your unit tests are going to be greater in number, but your UI tests, fewer in number, will be covering a lot more code for each test. So maybe a better way of representing that test pyramid is this sort of test square, which kind of implies that you're getting more or less the same amount of line coverage from each tier of tests. But this kind of suffers from the opposite problem. This now says you've got as many UI tests as you've got unit tests, which you probably don't want, unless you like having a test suite that takes 6 weeks to run, which I don't. So maybe this is the right model. Remember those kind of bubble tubes that were really fashionable in 1999 for about 10 minutes? And they used to grow algae, and you had them in offices? No? I'm old. So maybe this is the kind of representation of what your stack of tests look like. You've got a bunch of unit tests at the bottom, giving you roughly the same amount of line coverage as a few UI tests at the top, and you've got varying amounts of tests in between. But this is a bit of a digression. This model isn't really possible in a code base which hasn't been designed to have tests fitted low down. And there's that catch-22, which I'm sure you're all familiar with. You can't refactor because you've got no tests, but you can't write tests until you refactor. So to move us towards that ideal solution, we can use some familiar tools, but we can use them to do slightly different work. The photo on the left is an old boat that I helped restore. That's my thing when I'm not working. I like to restore old boats. The sticky up wooden looking bits. Has this thing got a pointer on it, a laser? At the risk of breaking things? It has. These things here are called ribs, and they're made from oak. And the way you bend them to the shape of the hull is you stick them in a steam box and you heat them up for an hour or two, and then you slap them against the hull, and you and all your mates tread on them to bend them to the shape of the hull, and then you rivet them in place. Restoring this boat, we had a problem. This orange piece of wood up here, which is called the beam shelf, is in the way. You can't slap the rib up against the hull. You've got to feed it down through that slot between the beam shelf and the hull there. And this isn't the problem that a boat builder would face if he was building a boat from scratch. But we're working on an old boat where we're in a kind of constrained condition. So the way we got those ribs down through that gap and around the bend of the hull and riveted in quickly before they went cool and started breaking when we tried to bend them was we used a spade. We used a garden spade, and we wedged it out behind the beam shelf and then used it as a kind of movable skid to sort of bring the rib down. And as far as I know, a garden spade isn't a part of a boat builder's toolkit. It's using a tool to do a job which it wasn't really intended for, to get around some kind of limitation. And lost my thread. How does this relate to testing? Yes.
It kind of relates a little bit. So who's got experience using coded UI tests? How robust are they? Crap? Quite? Crap? Yeah. So the spade, or the way I like to think of it, is kind of scaffolding. We need a tool to test our stack. Coded UI tests will do that. They're a spade. They're probably not the best solution for that. You certainly wouldn't go, I'm going to test this entire product from beginning to end using coded UI tests. That would be crap. But it's more like scaffolding. So you want to build some scaffolding that's relatively rigid. You don't want to live in the scaffolding. When you think about building a house, you kind of use scaffolding to build up the walls. The scaffolding has massive holes in it, but there are some parts that are quite rigid, and there are some parts that allow you to build the house using scaffolding and then kind of tear it down afterwards. We're not talking about using it as an ivory tower and building a whole bunch of coded UI tests that will be the way that we will test forever. But this is kind of the necessary that we had to do, or that we have to do now to move us towards our ideal solution.
Yes, so our test pyramid at the moment is an inverted pyramid. We're getting a lot of coverage from a large number of UI tests, and the tests which would ideally be greater in number and providing an equal amount of coverage further down the stack are fewer in number and not providing as much coverage because we can't get them in there.
So when I was thinking about what the ideal solution would be, as a kind of QA practice lead, I had a couple of goals. One was something that's good for zero, and the other is something that's good for QA. And kind of when I think about QA and what I've seen in the past and what I still see sometimes in our industry, not as predominant nowadays, but certainly there are a lot of QAs out there that don't understand code. And that's kind of like having a racing car driver who doesn't understand motors. If you all have watched, I don't know if you have, it's quite old now, Days of Thunder with Tom Cruise in it. So he's a...
I love the fact that you're using Days of Thunder as your inspiration.
It loosely fits, loosely. He's a racing car driver. He starts out, he's good, he's got a lot of talent, he's excellent, but he keeps crashing the car, blowing the engine, smashing into walls, because he doesn't understand how the car works. In the movie, they go through, they teach him how a car works, they teach him when engines are likely to blow up, and he saves the day and wins the races and gets the girl and all that kind of stuff. This is what we were after. This is what I was after for my QA. Is I want them to have the skills to know and understand what they should be doing and what they shouldn't be doing. And I want them to have information, so I want them to be able to see the output of tests so that they can understand where they need to test more, where they need to explore more, what's being automatically checked they don't have to worry about. And this, of course, saves time. So we no longer have this large manual regression exercise that we do every, N times we release code. But we now have more time to invest in not only writing the test, but also in building new software and testing new software. And we get this thing which is quite relatively rare in an industry. I've been trying to hire them, but technical QA, so QA that know more about code, that can write good, robust tests, that can start to look further down the stack, so API layer and below into the integration layer as well. And we don't just get one or two of them. It's not a small team doing this. It's every QA, every team that's building product has QA in them that are writing tests. And then when I think about what Xero gets out of this, so Xero's ideal solution is that we have something that will allow us to move with speed. So we'll be able to deliver code quickly, test it quickly, and iterate on it as we need to. We also get clarity. So being a lean kind of company, documentation around what our code actually does, how it behaves, is light, Spartan maybe you could say, but there's very little of it, and we only have really our QAs and the developers to understand how the code works at any level. So if we want to do something new with that code or interesting in a different space, the only way we can find out about it is by asking either the developer who wrote it, if they're still with us, or the QA who worked on it, if they're still with us. So we really need something to document this and to write it down. And this allows us to do what we want to do, which is change the underlying infrastructure to make it more testable, to break it up, to allow us to scale as we want to scale, and all of that kind of good stuff. Sorry, thank you. This has some animation on it, which isn't working. How do you do that? Not like that.
I think something's failed in the translation from.
No, shit.
I think something's failed in the translation from Google Slides to.
Can you work on getting that back up on the screen, please, technical guy?
Where's present in PowerPoint? I haven't used PowerPoint for a long time.
So
talk among yourselves.
So who's working in Agile here? A lot of you. So you're all fairly familiar with what a story is, how a story works. Yep. So there's a really good book by a guy called Gojko Adzik called Specification by Example. Has anyone read that? Nope. Couple? Yep, cool. What he talks about in there is this idea of using examples to specify what you're going to build. So basically a story is this as an idea of a persona. I want to do something to get some result, which is great, and the team kind of understands the overarching reason why, but where I get involved and where QA and devs can work together is understanding the two things that kind of come out of a story. There's two kind of critical questions that any team should really be asking. One is, what's the acceptance criteria? So how do we know we're done? When can we stop safely? And if a team understands that, then they know when they can finish work and when they've succeeded and what success looks like and all that kind of stuff. And the second is, how do we prove that to ourselves? So what are the examples which are going to help us exercise that? And Gojko's book is basically about that, about getting teams together to understand what the examples are that will exercise the code that they're writing, and making those examples quite succinct, making them really good, making them clear so that there's no ambiguity, there's no more, I thought it would do this and I kind of say, oh no, I think it should do something else. What we're hoping to do and what we've been doing is taking that kind of to this other level of automating those key examples so that you gain something called a living specification, which is you know how your system works, it's all written down, and it actually works that way. So it's not a specification that kind of, it was true the minute and, and kind of went out of date the minute it was written. It's a specification that has to be true because it's tested all the time and the results are correct. So, we understand where we are. Transition over. So how do we move towards that in Xero? What's our ideal stack look like? So we have a lot of C# developers, a surplus, not necessarily a surplus. That's not the right word, but we have a lot of them. We
have the opposite of a surplus, like if we are hiring, if any of you are.
We have a surplus of C# talent, maybe that's a better way to describe it.
It is overflowing. the talent pool of our C#.
So it makes sense to use a tool set that supports C#. We build marvelous applications using C#. Why can't we build something in the test space using C# as well? It turns out we can. If we combine it with things that support that specification by example layer, which is SpecFlow in this instance, or MSpec is very similar to that. And these are things that give you a kind of a human readable context around the test execution. And then Selenium's fairly obvious choice for anyone doing UI testing. It's free. It works pretty well. There's a large community online that supports it. So it is very, very obvious as a choice. And then abstractions, so taking as much of the detail of the test and as much of the repeatable code that would naturally occur if you went and built lots and lots of kind of test scripts, moving that away into a layer or into layers where it's only touched and used in one place. That's kind of our ideal solution.
Cool. We also had some, I guess, non-technical design goals. Hands up who's doing some sort of agile. Like Scrum, Kanban, okay, everybody. Keep your hand up if you're doing some sort of agile along the lines of the Spotify model. Okay. So cross-functional teams. So within Xero, we've got a technical team of 110, 120.
Tribes, squads,
and within that big pool of talent, we've got small cross-functional teams with a couple of devs, a QA, a front-ender, like some DBA resource, all of the skills that you need to deliver a feature, or to refactor some code, or to break out a service, or whatever it might happen to be. So is everyone doing something like that? Cool. Okay, good half. That's really cool. Actually, it's really encouraging. There's a whole bunch of benefits to working in this way, and it seems to be like really popular. TradeMe are doing it, Xero's doing it, Parts Trader are doing it. Like a whole bunch of firms that I regard really highly are doing it. I won't go into all of the benefits of doing that. That's probably a thing for Agile NZ. But relevant to this talk, citing QAs and devs next to each other, literally adjacent desks, it removes a lot of that them and us mentality. It means that instead of the developer writing some code and then sending it to the QA and the QA going, I found a bug in your code, you've got it wrong, and the developer saying, no, read the spec. They're on the same team. They're both kind of looking at the problem and going, okay, how can we deliver this piece of product to a quality standard that we're both happy with? And QAs engage a lot earlier in the development process. So when the QA is writing their test plan, they'll turn to the dev at the next desk and they'll say, hey, what happens when Thruppet goes skew on triddle? What should the system do then? Should it throw an exception? And the developer will say, oh, I hadn't actually thought about that. Well, let's figure out what happens when Thruppet goes skew on triddle. And
what's a Thruppet?
It's from Monty Python. It's the bit before the Spanish Inquisition. I was told to come in here and say Thruppet's gone skew on triddle. I didn't expect the Spanish Inquisition. Nobody expects the Spanish Inquisition, and so on and so forth.
Was that in the spec?
What was I talking about?
Sorry.
That's it. I didn't expect the Spanish Inquisition. QAs engage much earlier. QAs, devs work together. Okay, yeah. So the dev will go, oh, thank you for pointing that out, QA. Let's figure out what should happen when Thruppet goes skew on triddle. And that case will be caught before it's built, rather than being caught right at the end in testing. And the other thing, as we move to a model where QAs are living in Visual Studio and writing code, which we're going to talk about some more in the coming slides, it's much easier for QAs to get technical help. It's very easy for a QA to turn to the guy at the next desk and say, hey, which namespace is String Builder in? The developer can just say, I don't know, ReSharper will tell you. But it's much easier for that question to take place between two desks than it is between two offices, or between two buildings, or between two cities.
Yeah, I agree. Yeah, exactly, and that's kind of the whole point. There's no more us and them. There's no more chucking stuff over a fence. There's no more QAs kind of stuff landing in the lap, going, I don't even understand how this is supposed to work. Nothing's written down. We all get together. We understand what's going on, and we're all committed to the results. In the same way that I'm equally committed to this talk. It's not all your fault. It's mostly mine, but that's fine.
I'm not sure whose fault that slide was. We'll have a retro.
So the solution that we came up with is Zero C, and I'll talk a little bit about how it's structured and how it's set out. So it's broken into three main parts. One is a framework, and the framework is kind of the bones of it. So Selenium, if anyone's used it, is really good to use, and it works really well on a local machine. When you start to get involved in things like pre-prod environments that are naturally a bit slower, you start to code in really kind of waits and sleeps and all kinds of malarkey that you don't really want corrupting your tests. So we handle that in a framework. The framework is the only thing that talks to Selenium, and it does all of the waiting and the sleeping and all of the kind of making sure that things are actually there when they're supposed to be there, and that they're clickable when they're supposed to be clickable, all that kind of stuff. That Selenium kind of handles, but not very well. And then we've got a model, and the model is kind of like the road or the UI map of Zero. So as you can imagine, the model is pretty big. But it's a single place for every page in Zero. So there's only one model. Any test that needs to talk to the model only has to talk to one place. If we change a page and we're not changing a functional flow, we only have to change the model, and then the functional flows continue to work. So we put a bit of thought into that and structuring it in a way that makes sense for lots of tests to be able to leverage it. And then the tests themselves, so a bunch of different tests across a bunch of different application areas, using SpecFlow and using step definitions and all that kind of stuff. But we're trying to take all of the complexity and put it into either the model, well, actually mostly in the model. The model also includes, I forgot to mention, some helpers, some helper classes around connecting to databases, using RESTful API calls, all that kind of stuff. Actually, it's not the model, it's in connectivity, sorry. I've gone off track.
What is that?
What?
That next to the Chrome logo, what is that?
That's
like the
Firefox.
worst Firefox logo I've ever seen. This was drawn with a crayon.
It's not my fault. It's Lemio, so Lemio chart is how I did this. I clearly don't design Zero, as you can see.
Hashtag beautiful.
Yep, ownership.
Should we dive into the code?
Yeah, so I'll have a look at the code, and I'll show you a bit about what Zero C looks like.
Which note is number one?
Oh, yeah, thank you.
Oh, is that working?
Yes.
Excellent. This is an Ignite first. This is a QA in Visual Studio, live on stage. There's no trickery. Nothing up my sleeves.
Thank you. So this is the entire solution, and as you can see, it's quite large. There's lots in here. These, like community, SE tests, header SE tests, reporting, these are all different applications that are leveraging the same framework and the same model. This is a bit of a monolith in its own right. And down here you can see the framework here and the model here. So if I open the model, we can see that it's broken into some helpers, a page model, which actually gets ridiculously big if you start to look at some of the things like 0 pages. Again, it's trying to be unique so that you only have one place to change if something breaks. And then we have the Zero C tests themselves. So these are the tests that are to do with the Zero business application. So we'll have a look at one of those that, actually I've got it open. We'll have a look at one of those that you guys might be able to understand. Who's using expense claims this week? Couple of people, yep. So here's an example around Zero expenses. That is quite easy to understand, and this is the type of scenarios that we're doing. We're not building out hundreds of scenarios and expense claims to give us total coverage. We're building one scenario that exercises that feature to a point of largely working, and then saying, okay, we're done. We're going to move on to another thing to get some of that kind of bubble coverage. In this scenario here, we're just ensuring that in order to authorize an expense claim, you have to have approved receipts or declined receipts. So they all have to be approved or they all have to be declined, or else you can't approve it. So we have 4 different scenarios, and they're just the normal, approved, declined, awaiting review, can't be authorized. Approved, declined, approved, can. Approved, approved, can. Declined, 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 can. That's fairly easy to read at a human readable layer. It makes sense to me. Does it make sense to most people here? Cool. That's the idea, is that anyone can come along and go, yep, that makes perfect sense to me. So let's have a look at how we do some of this stuff. Firstly, one thing to note at the top of the test here is that we have a function tag which is called, it's just a tag, so this is just kind of decoration. And it's at login as standard Rose user and go to the dashboard of New Zealand org. This is stuff that is not necessary for the test, but it's necessary to actually run the test. You have to be logged in, you have to be authorized, and you have to be in an organization. So we have it up there. It explains where you need to be, so if you have to debug it, you can actually go into it and debug it. If we look at one of these steps, so given I've created 3 receipts, let's go into that. Okay, so this is given I've created 3 receipts. So how do we create those 3 receipts? There's a method in here called create receipt. Let's have a look at that, which calls cloud receipts. So into there. Cloud receipts is using the API, and this is something we've done to help increase the robustness. So we're not doing everything through the browser. We're not doing some of the setup steps that we need to do through the browser. We're doing them through API calls, or in some cases, really, not my ideal either, but injecting into the database to do some of the setup stuff. But we're not driving it through the UI because the UI is incredibly intensive and more prone to failure the longer you're in it. So we do things to set up data using API calls because they actually work relatively robustly. And then let's see, there's another. Oh, too far. So yeah, what's the next step on here is given I submit the 3 requests for approval. So this feels like it's a user action, and you can see in here we're navigating to somewhere. We're submitting all receipts for approval, and we're clicking expense claims link class. So let's have a look at that and see what that does. So now we've moved into the model, and we're in the expense claims page. So one page that has all of the information about how to do things on the expense claim. And you can see on here we're calling, so we're using that. Let's have a look at one of these that you'll do. On the same page, so higher up in the page, at the beginning of the page, we have the identifiers for what's on that page. So this, in this case, this is a button. We've given it a name that makes sense. We're identifying it using XPath, and there's the XPath there for everyone to see. So if that does change, you can kind of change it. You can use CSS, XPath. We prefer to have IDs. So some of these actually do have IDs on them. But of course the older pages don't because no one wants to touch them, and they don't want to touch them just to add IDs. There's not a lot of time for that. So we have to use XPath. So we try and make it as robust as we can, but occasionally it changes. So then we go to what we're doing with that. So here we're taking that button and we're going to press it, wait and click. So this is where we're moving into the framework. And inside the framework is where we'll put all of the kind of wrapping around Selenium to make sure that it's definitely there, it's definitely able to be clicked, and then once we've clicked it, that we've asserted that we've clicked it, and it makes sense to assert if we've clicked it. So I'll go right down to the layer that actually uses Selenium. Did I go off? Did I get on the wrong thing?
No, wait and click internals, the one I think.
Wait and click internal? It is, yes. Okay, so in here, right down in this layer, this is where we use Selenium. So iWeb Element is a Selenium feature. You could just use this directly. You don't have to use a framework. We've found the framework really, really good to make it robust. If you do use iWeb Element and you do start to use just pure Selenium clicks, then I would advise being prepared to have a lot of sleeps in your tests and a lot of waits and a lot of loops, which is what we've kind of done in the framework. Although by doing it in the framework, we now just call wait and click. So every method does the same step, wait and click. If we need to make a change, we can make that change once on wait and click, and it will affect every test. And this finally gets down to the point where it actually calls selenium.click and returns back something from there. So that gives you a little bit of an explanation of how the tests work. There is something else that Ben wrote, which is connectivity in here, which is, I'll let you explain it. You wrote it.
Sure. Who's a dev? Hands up, devs? Cool. So connectivity is basically, poem, if you will, to how much I love Fluent builders. So the idea behind this was to give QAs who probably aren't used to using database connections and RESTful services and that kind of thing, a nice Fluent discoverable interface over those sorts of resources. So it all starts with this from class. You can take things from a SOA service, which is 0Es for a RESTful endpoint, or from a database, or from a resource file. Let's jump into a SOA service. A SOA service is a Fluent builder, so it's got all of these various. You can construct one with a URL here, and then you can build it up with information that you might want to send off with a request, so users, headers, those kinds of things, and then ultimately you express it by calling. Let me find where that's used. Yes, you express it by calling one of these get result methods, which bundle all of that stuff that you've added to the builder up, turn it into a web request, fire it off, and it comes back as, you can either bring it back as a dynamic, which is a deserialized version of the JSON that comes back, or I think there's a sort of wrapper class which gives you a bit more information about the underlying HTTP stuff, which is good for if you want to investigate errors that come back from endpoints, that kind of thing. The reason it's all as dynamics is the DTOs that are returned by RESTful calls are in other solutions. We've kept 0SE and the tests that are written against SE in the same solution, rather than putting the tests in the solutions under test and then having to, whenever you want to make a change to the framework, go to another solution, make the change to the framework, publish a NuGet, pull it into the thing you're testing. So there's a couple of ways you could go about tackling that problem. We've gone this way, and one of the unfortunate drawbacks is everything's a dynamic, which is, it is what it is. Let's see this in use. Find usages. Should be something in 0SE, I think. Contacts. Have a look at one of these. Okay, there we go. So there's some results from a SOA service with a URL. Add a bunch of stuff to the builder, call a get result on it. And you can see that kind of pattern in use in lots of these tests against RESTful endpoints, databases, mainly RESTful endpoints. And as Craig was saying, this is really useful because it means you don't have to do everything through the UI. You can throw stuff at a service, and the idea is it'll be created in a database somewhere. You can then go and check that the stuff that should be showing in the UI, if that stuff is in the database, is there, without having to go through two different bits of the UI. That's probably enough on connectivity.
Yeah, I think so, yeah. Should we go back to slide?
Oh yeah. Use the magic fader. Cool.
So SpecFlow in itself is actually really cool. They've thought about it quite a lot. I don't know who's familiar with Cucumber in here. Anybody? A couple of people. Yeah, very similar. So just Cucumber for C# has hooks, a bunch of things that allow you to do preconditions and postconditions to anything, scenarios, test runs. So what you do is you call like before a test run, you might want to set up something, and then that'll execute, and then at the end of the test run you might want to, I don't know, tear down the environment that you're on and reset it up again. You can do that before scenarios. You can just decorate it with a before something and call a tag in the way that we saw tags being used, and that will just call that piece of code, do that step, and then take you back to your test. So you can actually remove all of the context except for the example that you want to execute, the example that actually matters. You don't have to have a really long-winded example where it's really hard to work out what you're actually testing because you've got 50 steps and most of them don't really matter. It also has something called scenario context, and scenario context allows you to see the current scenario under test when it's running. You can actually investigate and have a look at that context on the fly. Our kind of primary use for that is to see if the scenario is failing. If it is, take a picture of the screen, show us the results, show us any log messages, so that when we're debugging, we've got a bit more information to go on rather than just a failure, and then I have to go and manually see if I can look at it. You actually get a screenshot of the failure. You get all the log output of any exception messages, which you actually get in the test anyway. But it's quite useful. And then tags are the other one. So tags allow us to do a few things. They're just to basically at Craig or at login or at anything. They're all free form. You can put as many tags in there as you want, and you can do different things with them. You can use them to bind to hooks. You can use them to run separate things on execution, or you can do nothing with them, or you can do what we're doing with XUnit as well. So we use some of them to hook and some of them to actually log us in as a user and do some sort of functional action. And then we use some to use as run tags, which is basically taking that tag, and we use XUnit to run as our test runner. So we're changing that tag into a trait, and then it allows us to break what would be a really large test run into a bunch of smaller test runs, which equally makes it shorter to run, but also faster to debug. So if you run 300 tests and one fails, you don't necessarily want to run all 300 again just to get that kind of green thumbs up. So we split them into smaller groups, which makes it easier to find the failure and then easier to re-execute the test pack again to get a pass, which is cool. The other thing we do, moving into CI, you need to surface information. It's kind of crucial to anything that you're doing in CI. We don't have kind of the NASA Mission Control Center, but we do have a few things which are quite critical to us. So we see the output of testing in our CI server. We log, all of our tests actually log inside a log system, and we can extrapolate from that a bunch of different stuff using not really big data, but using analytics to see the time it takes for tests to run, the frequency of test runs, the more robust test suites, the less robust test suites, the environments that they run on. We've got something like 50 pre-prod environments. So we're running tests all the time. We run up to 300 or 400 test builds a day, which is a lot. And then being able to log and see the logs for that is much easier to investigate than actually having to go and investigate the single results for each test run. And we use a wiki, or an intranet if you're still from 5 years ago or 10 years ago, 5 years ago really. And the wiki is kind of our way of making this information accessible on a global scale. So we have QAs in New York and San Fran, Auckland, Wellington, Melbourne and Canberra, and this is a solution that they all use. And as nice as it is to sit next to Ben and kind of say, well, how do you do this? If I ask him more than 3 times, he's probably going to punch me. So we write it down and we share that information out so that people can see it in different countries and they can leverage it in a way that makes sense for them.
Sweet. Okay, where next? So do you want to unlock that as well? We may need it again. There's, I think, this idea of hats. So in any given organisation, there's a bunch of work that needs to be done. There's like 100 tasks that need to be done, and there's only 20 people to do them. And different people wear different hats at different times. So in every organisation, there's probably a need to go and find out what it is your customers want. And in some organisations, the person who does that is going to be called a BA, and in other organisations, they're going to be called a product owner. In little startups which have got 3 people, it's going to be whoever's not fixing the build at the time. But that work he's doing, and someone's going to wear that hat. Traditionally, the wearing code hat has been worn by devs, and the doing testing hat has been worn by the QA. But what we started to notice using SE and co-locating devs and QAs is that they're swapping hats. So there are devs who are saying, oh yeah, I can jump in and write some zero SE tests for you. And there are a few QAs who are saying, I'd like to do more dev stuff. And a couple of them actually come to me and said, I'd like to be a dev. And I've said, well, you kind of are, you're already writing code. If you want to write application code, then just talk to the devs in your team and say, hey, I'd like to write some application code. And they'll say, sweet, you're writing code, you're writing SE code, I'll give you a hand, cutting some feature code. And maybe I'll have to write some more tests because you're going to be busy doing that. But the distinctions between dev and QA are starting to blur and they're starting to break down. And the devs are wearing more of a QA hat as well. They've been hanging out with the QAs. And they've kind of learned some of their wily, tricky QA ways. They're starting to think more like QAs. And C# is becoming a ubiquitous language that devs and QAs can use to talk to each other. There are a couple of pitfalls. I'll just jump back quickly into Visual Studio for a second, and I will show you.
We're trying to correct this as well, just before he slams us. But yep.
With this class here, who can imagine what PageBase does in a code base which deals with interacting with the browser? Let's just jump to the end of it. 5,426 lines. So PageBase does everything in the world. And this is what you'd expect. The page is a big concept in coded UI testing. It's the invoice of coded UI testing, or the auction for my TradeMe friends in the audience of coded UI testing. You would expect logic to accrete around this big concept. This is a thing that happens in code bases. And a lot of the people who've been working on Zero SE, remember, are QAs. They're not developers. This is the first year that they've been writing lots of code. You would expect this to happen. I think with hindsight, I would have appointed some sort of technical oversight over Zero SE, some kind of technical champion, but I didn't, because I was, doing something else. And I don't mind too much. Like, we've got a load of coverage, and we've got a really good framework that we wouldn't otherwise have had, and I wouldn't trade that for a couple of God classes. So, yeah, and hindsight's 2020.
So for the framework and for the tests, we're not building an ivory tower, but I always want it to be better than it currently is. So we're using SpecFlow with XUnit 2.0. XUnit 2.0 can, in theory, run tests in parallel. SpecFlow, up until last night, couldn't. So there was a pull request merge last night, which allows you to run SpecFlow with XUnit 2.0 in parallel. So we're going to get that, hopefully by Monday it will be working, if all goes well, which would be awesome. So that reduces the overall running time to potentially your longest running single test, which would make a huge difference in terms of CI. One of the other things we want to do is capture the traffic that these tests create and play it back at load. So capture HTTPS, HTTP traffic, and actually play it back at load. We're investigating that at the moment and have some promising results. What you would get out of that, if you kind of think about it, is you start to get not only single flow load testing, so the creation of an invoice at load, but you actually get whole system load testing, which is quite cool. And if you can see that on a pre-prod environment or on a DR side or something like that, you can understand where bottlenecks are in your business model. The other thing we want to do is open source Zero SE. I think, I don't know if Ben's put you off with PageBase, but it'd be good to share it out to a bunch of other people, or at least have a couple of articles about how and why we chose some of the things we did.
I should do a quick straw poll. Who would potentially use Zero SE? Holy shit, that's half the audience. All right, okay, we'll open source Zero SE. I've said it, so now we have to do it. I don't know if I can say it, but
sweet. Okay.
All right, expect it on Monday. Awesome. Okay, takeaways. There was a talk this morning that said takeaways is a food and not a slide, but tough. Scaffolding isn't pretty, so you can build tests at the UI layer that do work that maybe you'd rather other tests were doing, and it's okay. They're not forever. If you're building a framework, which you're not, because you're all going to use Zero SE, because we're going to open source it, get good separation of concerns in, separate the execution of your tests and the intent, pull things out and give things meaning with names. This doesn't have to cost a lot. We've done it all with free tools. Get your QAs and devs studying together. That's probably the biggest thing, actually.
Yep.
Get that knowledge transfer happening, and get everyone cutting test code. And I don't think anything that we've talked about today has been particularly complex or conceptually difficult or revolutionary. It's not easy. You need everyone on board. You need to get that buy-in. There's a lot of work kind of getting the mindset where you need it to be. But if you can bring your QAs and developers together as we're doing, you're building a team of people with really quite rare and very, very valuable skills, and they're people you can't go out and hire. You'll actually have built a team with superpowers.
Yeah, I've tried to hire these people. They're either locked up solid in organisations and they're not letting go of them, or you just can't find them. They're very, very rare technical QA, and we solved that problem by actually just making our current QA team technical QA, almost by saying it and then having it happen afterwards. So it was really quite inspiring for me to see.
Awesome. Related sessions, there isn't really anything, certainly not anything coming up. I think Stop Coding on Pigs is going to be an awesome session. I'm going to be going to that. You should go and see Kirk and Felix's session tomorrow because they're awesome presenters, and you should go and see Ivan's session for the same reason. We're taking questions now, or downstairs at the hub over beers, or downstairs at the hub over beers, or downstairs at the hub over beers. Thank you. He's been Craig, I've been Ben. You've been a great audience.
Thank you very much.